Hello, and we're going to take a look at chapter 9.1.2, which is the volume and surface area of prisms. What you should do now is open up in Canvas the 9.1.2. It says V and SA of Prisms, number 16 and 18, and that's the assignment I'll be going through right now. Before we get started on the actual questions, we need to talk about prisms. And a prism is a special type of polyhedron. It must have two congruent parallel bases that are polygons. Also, its lateral faces, which are the faces that connect the bases, are parallelograms formed by connecting the corresponding vertices of the two bases. The note here is that the lateral faces may be any type of parallelogram, such as a rectangle, rhombus, or square. Now, when you're looking at these two examples, the first example over here is a prism with a hexagon base. So the two bases are going to be the two sides that are congruent to each other and that are parallel to each other. Notice that in this case, since this is a right prism, and we'll talk later on about what right means, that all of the lateral faces are rectangles when you're doing that. When we look at the other shape here, the two highlighted sides are the bases. Now, a lot of times when we hear the word base, we think of bottom, that's what the base is. But the base is not always going to be the bottom. The base is going to be the two parallel, congruent polygons, which is what we have highlighted here. Now, the tricky part here is to figure out the height. A lot of times when we think of height, we think of it typically going from the bottom to the top. But when we're talking about prisms, the height goes from one base to another. So another definition of height when you're talking about prisms is the distance between the two bases. So that would be considered the height in this prism. Okay, so now we're going to take a look at the first question that is going to be in your assignment, 9-16. It says, Paul built a tower by stacking 6 identical layers of the shape below on top of each other. What is the volume of this tower? Before we get into that, we should talk a little bit about what volume is. Volume is just how much space some three-dimensional figure will take up. In this case, if we look at each cube individually, we'll say that it is 1 unit wide, 1 unit tall, and 1 unit deep. That means that each one of these little cubes is going to give us 1 unit cubed, or 1 cubic unit. So to figure out the volume of the bottom layer, all I would need to do is count how many cubes make up that bottom layer. So we have 1, 2, 3, 4, 5, 6, 7. So 7 cubes make up the bottom layer. So if I were to stack 6 of those on top of each other, that means that each layer that I put on here will have 7 cubic units. So when I stack another layer on top of that, that will have another 7 cubic units, and another layer on top of that will have 7 cubic units, and another layer on top of that, and another layer on top of that, until we have stacked up 6 cubic units. So to figure out the total volume, I just have to add all of those layers together, or we can multiply 6 times 7, because there's 6 layers of 7 blocks each, which will give me 42 units cubed. And that will be the answer that goes in your first one. The second question says, how can you tell without actually building them? So without taking the blocks and stacking them up, how would we know? So in this case, all you need to do is take the volume of the first layer, in other words, how many cubes make up the first layer, and then multiply that by how high your tower is. Okay, let's take a look at the next question. When we're looking at this prism, the first thing we should do is identify what the bases are. Remember, there's always going to be 2 bases. The bases are the parallel sides that are congruent to each other. Now, the parallel sides that are congruent to each other are going to be this right here, and then on bottom, the base that goes around the bottom there. Now, one other way of thinking about volume is to think about it in terms of the area of the base. Now, in math, we use a capital B to equal the area of the base. That's different from a lowercase b, which you might have seen in an equation like for the area of a triangle, where we say area is equal to base times height divided by 2. A lowercase b stands for the length of a side. A capital B stands for the area of the base. So when we think about this, we're going to think about finding the volume by saying it's the area of the base times the height. So when I look at my base, the area is just going to be how many squares make up that base. In this case, there are 4 squares that make up that base. And then we need to multiply by the height. Well, like the previous problem, if there was just one layer, if this was just one layer high, I would multiply that by 1, and I would get 4 units cubed for the first layer. In this case, there are 1, 2, 3, 4, 5 layers. So to find the volume of the entire prism, we would do the area of the base times the height. The area of the base is 4 times the height, which is 5, so that will equal 20 units cubed. And now we're going to talk about the surface area. So I'm going to get rid of what we have right here so far and give ourselves some space for the surface area. When we're talking about surface area, we're going to break it up into 2 basic things. We're going to talk about the area of the bases, and then what's called the lateral surface area. And then when you add those 2 together, that will give you the total surface area. So the first thing we're going to do is take a look and see if we can find the area of the bases. So we said before that the bases are going to be the congruent parallel sides. So that's going to be like the top and bottom in this diagram. I can just count and say this is 1, 2, 3, 4 units for the top plus 4 units for the bottom. So the area of the bases is going to be 4 plus 4, or just 8 units. Next, let's look at the lateral surface area. Now, the lateral surface area is the area that goes around everything that connects the bases. Now, in here, I can look at this side right here and try and find the area of these and these together. When I do that, all I need to do is just count how many squares make up this side. So it's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So there are 15 of them that make up this side here, which I'll just call the right side. Now, I have another side over here that's harder to see, that's the left side. The right and left side always must have the same surface area. And I wrote that wrong. So they always have the same surface area, so that will be a total of 30. Now, we also have the front, that is this part right here. And then we also have the back, that is the same as the front. So the front and back are always the same as well. So if I count those, it would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's 10 in front and 10 in the back, and that will give me a total of 20. So my lateral surface area will be the next part. I'm just going to abbreviate that, LSA. So the lateral surface area will be those 2 added together, which will be 50. So now we have the area of the bases, which is 8, the lateral surface area, which is 50, and that will give me the total surface area when I add them together, which is equal to 58. Go ahead and pause the video now and give the next question in your assignment a try and see if you can do it. And when you unpause the video, I'll go over that one as well if you run into any problems. Let's take a look at number 2. Again, we want to find the volume in the surface area. Before we do anything else, we want to identify the bases. Remember, the bases are the congruent parallel faces or sides. In this case, it's going to be the top and bottom. So when I want to find the volume, we have to do the area of the base times the height. So again, the area of the base is just how many squares make up the base. In this case, 1, 2, 3, 4, 5, 6 squares make up the base. So it's going to have an area of 6 units, and you multiply that by the height. Again, remember the height is not necessarily from the bottom to the top, but it's the distance between the two bases. In this one, again, it happens to be from the top to the bottom, but we count and we have 1, 2, 3, 4 units. So it'll be 6 times 4, which is equal to 24. Next, we want to find the surface area. To do that, I'm going to start off by finding the area of the bases, which we already did. There's 6 on top, so that means there's 6 on bottom for a total of 12. Then we need to find the area of the lateral faces. So to find the area of the lateral faces, or the lateral surface area, I'm going to first start off by doing the front and the back. Now remember, the front and the back will always have the same surface area, so I just need to count how many squares make up the front. So 1, 2, 3, 5, 6, 7, 8, 9, 10, 11, 12. So remember, the front and the back are always the same, so that'll be 12 plus 12, which will equal 24. Now, it's a little bit more difficult to see what's on the sides here. So if we want to look at the right and left side, it's a little bit more difficult to see. So we'll just kind of have to use our visualization a little bit and see if we can figure it out. Well, if I look over here at the right side, I see that there are 4 squares here. Now, you can't see them, but there's also going to be 4 squares going down there and 4 squares going down there. So if we did 4 times 3, that's 12. So to do the right and the left side, there's going to be 12 squares on each one of those, so that will also be 24. So now this gives us a total area of, and then when we add them all together, so 24, 24, and 12 will give us a total of 60 square units, or a unit squared. And I should have probably put the units up here as units cubed. So again, in this problem, we're going to try and find the volume and surface area. In this case, it'll be a rectangular prism. We're going to do a volume on this slide, and then we'll take a look at the surface area on the next slide. A rectangular prism is kind of unique in that it has 3 pairs of congruent parallel sides. So you could say that the front and back are the bases, or you could say the top and bottom are the bases, or you could say the right and left are the bases. For the purposes of doing this question, again, let's just say that the top and bottom are going to be the bases. So this will be my base here. So to find the volume, I want to do the area of the base times the height. In this case, I'm going to say that this is 10, this is 3, and this is 4. And I got those numbers from the problem in Canvas, so your numbers are going to probably be different than mine. Because it's a rectangle, I can find the area of the base by saying that this is 4 and this is 3, so 4 times 3 is equal to 12, so that'll be 12 times the height. The height, again, is the distance between 2 bases, so my height is going to be 10. So my volume is going to be 120 units cubed. In this slide, we're going to take a look at the surface area of this prism. Now, we have drawn out here what is called a net. A net is just a 2-dimensional outline of what the 3-dimensional figure would look like if it was folded up. So if you were to take this 3-dimensional shape and cut along these lines here, and cut along each one of these edges, and then unfold it, you would have a diagram that looks something like this. In this case, we called this the base in the last problem, so let's call this the base again here, and this would also be the base that would go on top when folded together. Then if you look at this, we could say that this would be the front, and this would be the back. Then this side would be the left side, and this side would be the right side. So to find the surface area, really what I'm doing is finding the area of each one of these rectangles. If we use the numbers from the previous problem, that would be 10 and 3 and 4. When I write those down here, that means that this would be 4 there, this would be 3 there, and the height of each one of these would be 10, and then this again would be 4 here, and that would be 3 there. So if I wanted to find the area of each one of these rectangles, I could just multiply length times width, which would give me 30, 40, 30, 40, 12 for this base, and 12 for this base. So if we add all those together, we would get 12 plus 12 for the two bases. Then we would get 40 plus 40 for the front and back, 30 plus 30 for the right and the left. And then if you add all those together, you would get 4, and that's going to be 10, 14, 15, 16, 164. Now, if we take a closer look at this, we can kind of do a shortcut in order to find the surface area. Before we always said that we're going to do the surface area in two different parts. We're going to talk about the bases. In this case, that'll be 12 plus 12, which is equal to 24. And we're going to talk about the lateral surface area. Well, if you look at my diagram here, the way we have it drawn out, the lateral surface area is the area of each of these, the back, the front, the left, and the right-hand side. Notice that they all have the same length. And the reason for that is that's going to be the same as the height. So if you went around to each edge on your prism, they're all going to be the same. So the only thing that's different is what's the length and the width of that. Well, instead of doing these separately, we can make a little shortcut and do it all at once. Because the perimeter of the base is the same as adding all of the sides of the front, back, left, and right together, I can do this in one step and say the lateral surface area is equal to the perimeter of the base times the height of the prism. Now remember, the height is the distance between the two bases. So in this case, the perimeter of the base, since this is 4, this is 3, this is 4, this is 3, will be 14 times the height, which is going to be 10. So that means the that means the lateral surface area will be 140. Now if we take a look at the two bases, that's going to be 24, 12 plus 12, which gives me 164. So we have kind of a shortcut now to find the lateral surface area. You just find the perimeter of the base and multiply that by the height, and that should give you the lateral surface area. Okay, that's the end of this lesson. Make sure you complete the assignment in Canvas. Good luck.